Okay, hello everyone. I welcome to all in our lecture series on Jacobian. In this lecture series, we are discussing these topics which are based on NEP syllabus. These topics are very much essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our last two classes, we have been discussed definition and application of Jacobian, properties first and second properties of Jacobian and their corresponding proof. In this class, we are going to discuss third and fourth properties of Jacobian and their corresponding proof. Okay, so let us start. So these things already have been discussed, definition and application of Jacobian in our first class. In our last class, we have been discussed first and second properties of Jacobian and corresponding proof. Here I forgot to write T. Okay, you can found in our last video I forgot to write T over here. You just correct in your note. So last class we discussed property number 1 in detail and property number 2, that is your chain rule for Jacobian, in detail. In this class we are going to discuss property number 3 and corresponding proof. Okay, so let us start. Here you can see, if functions u, v, w defined or constructed with three independent variables x, y, z are not independent, or you can say dependent, then Jacobian of u, v, w with respect to x, y, z, or you can say del u, v, w by del x, y, z equal to 0. That we have to prove. Here it is given that u is the function of x, y, z, v is the function of x, y, z, w is the function of x, y, z. Here x, y, z are three independent variables, but here u, v, w are not independent, they are dependent with each other. Then we have to prove this one. Okay, here proof starts. If functions u, v, w defined or constructed, same thing I written again, with three independent variables x, y, z, then an algebraic equation or polynomial can be written as f of u, v, w equal to 0. That means if this condition we have, then one polynomial can be written in this format. That means you can write u, v plus w square v square equal to 0, like this. A polynomial can be constructed like this if these conditions are given, that u, v, w are the functions of three independent variables x, y, z, and u, v, w are not independent dependent, then a polynomial can be written as like this. So in general, that polynomial is represented as f of u, v, w equal to 0. That means this polynomial is the function of u, v, w. Now the total derivative, if I am going to consider this one, total derivative of f, it will be how much? Df equal to del f by del u into du plus del f by del v into dv plus del f by del w into dw equal to 0. That implies del f by del x will be how much? Del f by del u, here del u by del x, del f by del v by del x, del f by del w, here del w by del x equal to 0. Let this is your equation number 2. Now consider del f by del y. Here del f by del u is there, del f by del u. Del u will be del u by del y. Here del v will be del v by del y. Del w will be del w by del y. Let this is your equation number 2. Likewise, if we are going to consider del f by del z, then we can found del f by del u by del z plus del f by del v by del z, del f by del w plus del f by del w into del w by del z equal to 0. Let this is your equation number 3. Now just write these three equations in matrix format as like this. Here this is a row matrix, del f by del u, del f by del v, del f by del w multiplied with this 3 cross 3 matrix. 3 cross 3 matrix, this is your 3 cross 1 matrix. If I am going to multiply these two matrices, then I can found these three equations. How? Here you can see this row multiplied with this column, I can found the first equation, del f by del u multiplied with del u by del x, This term I can get plus del f by del v multiplied with del v by del x. Here I can get the second term plus del f by del w multiplied with del w by del x. I can get third term equal to 0. Likewise, if I am going to multiply this row and this column, the equation 2 will be generated. This row, when it will be multiplied with this column, then equation number 3 will be found or can be generated. Now, if this into this equal to 0, that implies this value, this determinant value, you can say divided over this side, RHS side, and we can found this equal to 0, this matrix equal to 0, right? Now, same thing I have been written once again in the slide, in the next slide. Now, if I'm going to consider the determinant of this matrix, then what we have to write? This is in the matrix format. So in the determinant format, it will be del u by del x, same thing, del u by del y, del u by del z, del v by del x. Here this row I am telling del v by del x, del v by del y, del v by del z. This row del w by del x, del w by del y, del w by del z equal to 0. In our first class, we have been defined, may you remember, in our first class we have been defined this one. If we have this type of determinant, then this is nothing but your Jacobian of u v w with respect to xy. Del u by del x, del u by del y, del u by del z, v del u by del v by del x, del y del z, del w by del x, del y del z. That is nothing but your Jacobian of u v w with respect to xyz. So here we found the same determinant. That means we can write del of u v w by del xyz or Jacobian of u v w with respect to xyz equal to 0. Hence, we proved this property, right? This one, third property. Now we are going to go for our fourth property and its corresponding proof. Here, this is our fourth property of Jacobian. If u v w are implicit function of xyz, then Jacobian of u v w with respect to xyz, or you can write in this style also del u v w by del xyz, same thing, Jacobian of u v w with respect to xyz equal to minus 1 to the power 3 Jacobian of f1 f2 f3 with respect to xyz whole divided by Jacobian of f1 f2 f3 with respect to u v w. So let us prove it. Here, proof starts. If u v w are implicit function of xyz, here x, y and z are independent variables, okay, then three algebraic equations or polynomials can be written in this format. F1, which will be the function of u v w x y z equal to 0. F2 also will be the function of u v w x y z equal to 0. F3 also function will be the function of u v w x y z equal to 0. That means f1 will be written as like this, one polynomial. It can be like this, x square plus y square z plus w y plus vxz bxz, like this. That means one mixture type of a polynomial, mix all values you can found, x y z w u v, all value you can found, okay, equal to 0. This type of polynomial will be automatically constructed if this condition is given. That means if u v w are implicit function of xyz, then three polynomials will be constructed automatically. So here, if f1 is a polynomial or equation, you can see, which is the function of u v w x y z equal to 0, then if I'm going to write the total derivative of f1, it will be here, you can see carefully, df1 will be equal to del f1 by del u into du, del f1 by del v into dv plus del f1 by del w into dw plus del f1 by del x into dx, del f1 by del y into dy, del f1 by del z into dz equal to 0, because this function is the function of u v w and xyz also. Okay, so the total derivative of df1 is will be this one, this much. Now if we are going to consider del f1 by del x, then this value will be del f1 by del u, here del u by del x, because we are trying to find out del f1 by del x. Del f1 by del v, del v by del x, del f1 by del w by del x, del f1 by del x by del x, del f1 by del y by del x, del f1 by del z by del x. Okay, okay. Now here it is given that u v w are implicit function of xyz. That means u is the function of xyz, v is the function of xyz, and w is the function of xyz. But xyz are three independent variables. So here you can see the differentiation of del y by del x will be 0, because y and x both are independent variables. Likewise, del z by del x also will be 0, but del x by del x the value will be 1. So that implies here you can see this value del f1 by del u by del x, del f1 by del v by del x, del f1 by del w by del x, and here this value is your 1, del f1 by del x into 1, and these two values are 0, equal to 0 already is there, just written as such. Okay, that implies here three terms written as such, and this fourth term taken RHS side minus del f1 by del x. Let this is your equation number 1. Then consider del f1 by del y over here. That means here this term will be del u by del y, this one del v by del y, this will be dw will be dw by del w by del y, here this one del x by del y, here del dy will be del y by del y, del dz will be del z by del y. Here del x by del y will be cancelled out because this value will be 0, del z by del y will be 0, but del y by del y will be 1. Okay, so here these three terms written as such over here, and this term del f1 by del y taken this side RHS side, it will be minus del f1 by del y, and these terms are cancelled out. We got equation number 2. Okay, okay. Similarly, you just consider del f1 by del z. What you can found? This one del f1 by del u by del z, del f1 by del v by del z, del f1 by del w by del z, del f1 by del x by del z, then del f1 by del y by del z, del f1 by del z by del z. So these terms will be cancelled out, and we can found here these three terms written as such, and this term here del z by del z will be equal to 1, and del f1 by del z taken this side and written as minus del f1 by del z. Let this is your equation number 3. Okay, similarly we can get here del, here we consider what total derivative of f1, and then we evaluated del f1 by del x, and we found equation number 1. Del f1 by del y, whenever we consider del f1 by del y, we found equation number 2, and when we considered del f1 by del z, we found this one, equation number 3. Now you just think f2 also function of u v w x y z. Similarly, same, by considering same procedure, here del f2 by del u by del x, del f2 by del v by del x, del f2 by del w by del x will be how much? Will be minus f2 del f2 by del x. That is your equation number 4. Likewise, this one with respect to y, if I am going to consider f1, first I have to consider df2, then I have to consider with respect to y del f2 by del y, then I can found this equation number 5. Same procedure, we have to consider same procedure. Okay, for f2 equal to 0, we can found these equations, equation number 4, equation number 5, equation number 6. Here this much value will be equal to minus del f2 by del x, this much will be equal to minus del f2 by del y, this one, this much will be equal to minus del f2 by del z. Similarly, if I am going to consider f3, which is the function of u v w x y z equal to 0, consider its total derivative df3. Then here if I'm going to consider df3, then this will be del f3 by del u into du, del f3 by del v dv, del f3 by del w dw, like this. Okay, then you just consider del f3 by del x. You found this type of equation. Okay, that means you can found what? Del f3 by del u by del x, del f3 by del v by del x, del f3 by del w by del x equal to minus del f3 by del x. Similar, same procedure you have to consider. Okay, then we can found these three equations: del f3 by del u by del x, del f3 by del v by del x, del f3 by del w by del x equal to minus del f3 by del x. Equation number 7. Likewise, you can found this much value by considering differentiation with respect to y. Then you can found this much value equal to minus del f3 by del y. Similarly, by considering differentiation with respect to z, you can found this much term del f3 by del u by del z. This term equal to minus del f3 by del z. Okay, this is the equation number 9. Now consider this one. Here we have to prove uh, this equal to this. Now consider this one. What? Del f1 f2 f3 with respect to u v w into, or you can say Jacobian of f1 f2 f3 with respect to u v w multiplied with Jacobian of u v w with respect to x y z in determinant form. Next slide I written here. Jacobian of f1 f2 f3 with respect to uvw, Jacobian of uvw with respect to xyz. What we have to write here? The determinant form of this one is your del f by del u, del f1 by del u, del f1 by del v, del f1 by del w, del f2 by del u, del f2 by del v, del f2 by del w, del f3 by del u, del f3 by del w, del f3 by del v, del of f3 by del w. And the determinant form of this one equal to how much? Del u by del x, del u by del y, del u by del z. Here I written. Then del v by del x, del v by del y, del v by del z. Here this del v by del z mistakenly written. Okay, first I have to correct it. Just wait. So this will be del v by del z, and then del w by del x, del w by del y, del w by del z. Now we have to just multiply these two determinants. Okay, carefully. See, first we have to multiply this row and this column, first row and first column. Here you can see del f1 by del u into del u by del x written over here, plus del f1 by del v into del v by del x written over here, del f1 by del w into del w by del x written over here. Okay, then we have to go for this row, first row and second column. Del f1 by del u into del u by del y, here it is written. Del f1 by del v multiplied with del v by del y, here del v by del y. Then del f1 by del w multiplied with del w by del y written over here. Then this row, first row and third column, del f1 by del u into del u by del z, here del f1 by del v into del v by del z written over here, del f1 by del w into del w by del z written over here. Okay, likewise you just multiply this row, second row and first column. You can found this term, this plus this plus this, and this row, second column, you can found this one, this plus this plus this. Check it carefully. Okay, and write down note carefully also. This row, this column, we can found this much, this plus this plus this. I written correctly, you just write carefully. Then this row, third row, first column, del f3 by del u into del u by del x, del f3 by del v into del v by del x, del f3 by del w by del x. Okay, third row, second column, del f3 by del u by del y, del f3 by del v into del v by del y, del f3 by del w into del w by del z. Here del w, here no, correct, it is correct, del w by del y, correctly written, del w by del y. Okay, okay. Then third row, third column, that means del f3 by del u into del u by del z. Okay, del f3 by del v into del v by del z, okay, del f3 by del w into del w by del z. Okay, this is also a 3 cross 3 determinant. Okay, 3 cross 3 determinant has 9 elements. This one, 2, 3, 4, 5, 6, 7, 8, 9. Carefully you have to write in your note. Now put one equation number 1 value, 2, 3, 4, 5, 6, 7, 8, 9 equation values in equation number 10. Let this is your equation number 10. Okay, now we have to substitute these values, equation number 1, 2, 3, 4, 5, 6, 7, 8, 9 equation values in equation number 10. Carefully you just watch this one. Del f1 by del u by del x, del f1 by del v by del x. Here del f1 by del u by del x, del f1 by del v by del x, del f1 by del w by del x equal to minus del f1 by del x. So instead of this one we can write del f1 by del x. Here del f1 by del u by del y, del f1 by del v by del y, del f1 by del w by del y is nothing but your equation number 2 value, here minus del f1 by del y written over here. Okay, here del f1 by del u by del z, del f1 by del v by del z, del f1 by del w by del z is nothing but your equation number 3 value, that is your minus del f1 by del z. Okay, likewise this one, del f2 by del u by del x, del f2 by del v by del x, del f2 by del w by del x is nothing but minus del f2 by del x. So instead of this term written as minus del f2 by del x. Similarly you can found this much value is nothing but this one minus del f by del y. Try to just match this value. Then this much value del f2 by del w by del z, equal to minus del f2 by minus del f2 by del z, equation number 6, that is your. Here instead of this one we can write minus del f2 by del z, right? Likewise here you can see that this value is nothing but your equation number 7, and carefully you can match this value. Here you can see del f3 by del w by del y, del w by del y is your minus f3 by del y, that is your equation number 8. Here f3 by del v by del z, del f3 by del w by del z, del w by del z, f3 by del w by del z, yes, minus del f3 by del z. It is easy, but many equations you have to write, and you have to finally write the values here in this large determinant. So this value is your minus f3 by f minus f3 del f minus del f3 by del y, and this value is your minus del f3 by del z. Okay, now same thing I have been written once again over here, this one once again, no problem. So that implies this much into this much value will be equal to here each row, for each row I can take common as minus 1, here minus 1 into minus 1 into minus 1, that means minus 1 to the power 3 into this determinant, that is your del f1 by del x, del f1 by del y, del f1 by del z. Here del, here this one, del f2 by del x, del f2 by del y, del f2 by del z, del f3 by del x, del f3 by del y, del f3 by del z. This determinant is nothing but Jacobian of f1 f2 f3 with respect to xyz, this determinant. So we can write in this format that del f1 f2 f3 by del xyz, no problem. So that implies here this into this we found minus 1 to the power 3 into this much. Now that implies this value, that means Jacobian of UVW with respect to xyz then will be equal to, here right hand side we have minus 1 to the power 3 into this much written as such whole divided by this term. This term will be moved this side, so obviously whole divided by this term, that is your del f1 f2 f3 by del UVW, or you can say Jacobian of f1 f2 f3 with respect to UVW, hence proved. Similarly, it can be proved that del uv by del xy, or Jacobian of uv with respect to xy, equal to minus 1 to the power 2 Jacobian of f1 f2 with respect to xy whole divided by Jacobian of f1 f2 with respect to uv. So here this is your two variable case. What we have been done here in this video, that is a three variable case. Here u, v, w are the three variables, are implicit function of x, y, z. Then we proved this one. Suppose it will be asked that u, v only, u, v are implicit function of x, y. Then prove Jacobian of u, v with respect to x, y, or del u, v by del xy will be equal to minus 1 to the power 2, whatever I written over here. You just do this in your rough and prepare for your exam. Maybe in your exam it will ask for two variable. Okay, if you are going to do this one, you can found less steps as compared with these three variables. Okay, you just do your rough and then you write in your note for your exam point of view. Okay, so here in this lecture we have been proved the property number 3 and 4. In our previous video already we have been discussed in detail about property number 1 and 2. Okay, next class we are going to solve some important questions on Jacobian. So thank you so much for watching this video. Thank you.